So hello all. In the previous video, we are talking about what is a chameleon and what is the procedure of this chameleon. So in the previous slide, we have discussed that uh, what is the basically the bridge algorithm and the CF tree structure using this clustering feature in the bridge. So in the current presentation, we are talking about the that what is the chameleon. So basically, the chameleon is a hierarchical clustering using dynamic model, and it is given by the V. Kumar and E. H. Han in the 1999. So, it measures the similarity based on the dynamic model. Two cluster merge if their interconnectivity and the closeness, the proximity between the two cluster and high related to the interconnectivity of the cluster. So basically, it's a graph-based and a two-phase algorithm. The first phase is that use a graph partitioning algorithm, and the second one is use an agglomerative hierarchical clustering. So we are talking about the agglomerative hierarchical clustering algorithm today. So it's basically about the KNN graph and the connectivity things. The KNN graph, the original data in the 2D in the first neighbor, second neighbor, and the final distance. So the main thing is that the first we find about the relative interconnectivity, the RI, and Ri, the bracket Ci comma Cj, it's basically the ECICJ divided by ECCI plus ECCJ divided by 2. So it's basically ECCI or ECCJ, it's basically the ECCI CJ, the absolute interconnectivity between the Ci and the Cj, the sum of the weight of the edges that connect between the Ci to Cj. And the internal interconnectivity of the cluster is Ci, the size of its mini cut bisector ECCI, the weighted sum of the edges that partition the graph into two roughly equal. So basically the Ri things and the relative close RC things. The RCC is same. It's a S bar ECCI comma CJ divided by modulo of C upon CI plus CJ into S bar ECCI plus something CJ in the same form of CJ. So it's a formula of relative closeness. So relative closeness and these things are a relative interconnectivity we are using to find the which cluster we are going to merge. We will further see that with the example that how we merge a cluster. So that's the overall framework of the chameleon. That first we have a large data set entered in the form of a graph, and then the partition in the graph, and then merge partition on the basis of relative interconnectivity and relative closeness, and then make a final cluster of this. So basically the linkage method that in the final things we will decide that single link, the completing average link based on the minimum maximum the average distance of this. So based how to merge a small cluster into a large cluster, that is the thing. So we have two cluster. First we have in the cluster A the AB and the cluster to CD. That's the first two cluster, and the feature is ABCD, and the feature is 1 2 3 4 5 6. So this is 1 2 4 5 6. So if we calculate the distance metric between to A to E, and between A to A is 0, distance between A to B is 2, divide minus 1 is 1, and A to C is 4 minus 1 is 3, and D is 5 minus 4, and E is 6 minus 1 is 5. So same we calculated the from A, B, C, D, E, then calculated distance metric. And distance metric is about that single link, the complete link, the average link. It's a minimum, max, and average distance. Previously we have clear mentions in the terms of single, complete link, and average link. So according to after these A to B, A to D, A to E, and B, C, B, D, B, B, E. So cluster 1 and cluster 2. So we find the minimum distances between these, and the maximum distances, and the average distances between these two. So using what is the agglomerative algorithm, the start, the object, their measurement features, the computer distance matrix, and then set object. If the number of cluster is 1, then yes, okay, and if number of cluster is no 1, then merge the two close cluster and then update the distance matrix. Finally distance matrix updated, and finally see the number of cluster is equal to 1, then end. So it's agglomerative algorithms. So how we merge the clusters? If you see that using the agglomerative algorithm, so we find that we have two set that x1 and x2 in the form, so a, c, d, e, f. This time it is scattered data point. We plot this a for 1 to 1, b, so c. The data point plotting between the x1 and x2. So we find that we find a distance between the AB, the DAB is what is 0.07071 and the DEF so 0.5. So if we find the distance between the A to B, A to C, then A to D and A to E, and the B C B B B D B D, and the A to A 0, B to B 0, C 0. So we find that this distance. So we find what is the minimum distance between how many two cluster we have a minimum, because in the single link we find that what is the minimum distance between this. This is the minimum distance on the single link. So using single link things so that we find that what is the minimum distance between two clusters. So it's clearly mentioned in the reading 0.50 is the minimum distance. So which cluster we have to merge? So D and the D and F. So D and F that have the minimum distance between the 0.50. So 0.50. So D and F are merged into a single cluster and weighted matrix, say A, B, C, then D and F is merged. So E and the distance between two A that D, E, F to all the cluster we don't know. So the question mark is there. So a question mark. Then this we have to update this matrix. We have to update this matrix. So we find that we D and F2 merging and then find the distance between DF to A. So DF to A is a DA and a DEA. So DF to A. So what is the distance between DF to DA? So if we talk about that, what is the final this matrix is, and in this matrix is that distance between the, it's a minimum between the 3.61 is a distance that that called D to A and D2 and that D2 and F2A is make a maximum that F2A is say 3.20. So between this find the minimum distances. So according to minimum distances using single link, so minimum distance is 1.0, that is called say E. E is the next point. So I think the next point is the minimum distance between two. So then find the which way of the minimum distance apart from the 0.50, and the 0.50 is the maximum distance for 0.71 that between A and B. So A and B are merged. So A and B are merged, D and F are merged. Next, in the next level, then find the same distances between the A, B, and D, F. So what is the next level of this? Then A, B, then D, E, F. So D, E, F again are find D, E, F. So this is a merging. Then find the maximum distances. That is the minimum distance is 1, and between the D, F, E. So D, E, F. It's a DEF are merged, and these are merged and update the minimum distance matrix. So that is final things, and DEF are merged, then find the again maximum distances, then the C is merged, C, D, E, F, then AB is merged before, and the final merging is like that. The DF are merged, A and B are merged, and DEF are merged, and C is a single cluster, and the final result, that is a single cluster. So every single element form a cluster, that is the final limiting determination things are there between x1 and x2. So that is how to make a cluster using the agglomerative algorithms using this, and it is a dendrogram of the tree representation that first we have the 6 element, then merge which two type of DF and FR merged, then E and FR E are merged, then DF and FR E and C are merged, then A and B initially merged, the DFR space numbering 2, A and B the next step merging to 3, then 4, 5, and the final 6. So it's a dendrogram of this final things. So there are two other methods that we first discussed in the slide, that In the hierarchical method, there is a linkage method and a single things are there, that is a word method. The word procedure is commonly used, that is find the each cluster the sum of a square is calculated between the two and the smallest increase in the overall sum of the square. In the centroid method, the distance between the two clusters and the distance between the centroids. So this is the that word procedure. So find the a square of the distances from the each, and it's a bit basically the commonly used for the sum of the square of calculated. And the centroid method, we find the centroid of each cluster and find the distance between the centroid. If you talk about the time of space requirement of this, so in some times it's all about the zero of n square, and the next is n is number of points. But in some cases is all basically comes n cube also in many cases, when and finally it reduced we call of n square log n. In some approaches it is also being used. Strengths is there's various shopping website, electronic, computer, furniture, groceries, various things are various taxonomies, various biological taxonomies these are using in clustering. So any desired number of cluster can be obtained using this hierarchical algorithm using the dendrograms and the proper level. So basically there is a strength of this hierarchical clustering in the main field. Problems, yes, they have some problems, is they're breaking the large cluster sensitivity to the noise and outliers a single element that is left behind, and so what this is the problem for sensitivity and the final the noise or cluster. And if we talk about the large size cluster, so if it is a regular shape, so no problem in this. But if it is in regular shape, so hierarchical cluster, there is some problem for this. So there is some problem and limitations when the decision is made then to combine the two clusters. It cannot be undone because finally then because two clusters are merging for this for the same. Learning, so if you talk about the learning, that what we learn about the clustering things, the hierarchical clustering, various clustering methods, various methods, the algorithmic and the divisive hierarchical clustering things are there the two, also two other methods, the Dynard, Agnes, Bitch, the Chameleon, this type of things have will define intercluster distances, how the which type of distances are using and defining, the pros and cons of hierarchical clustering, the strengths and time complexity about the learning. So these type of learning here about this. So these are the type of references. So basically about the in the if you talk about that what we learned today from this, so I think the proper understanding about the hierarchical clustering is being transferred by me. And please like if you like this video, and you any improvement uh, from any technical point of view, any things are there. So about the clustering things and clustering procedures. So and about the what is various type of algorithms. So basically about the so thank you very much for watching this, and have a nice day.